Yeah, well, we're at the top of the hour. It looks like folks are still filtering in. But for sake of time, I think we'll kick it off now. And as always, we do record these sessions in case anybody needs to catch up later. So a very warm welcome and thanks for joining us for the first time or again for the second in our three-part series, Powering Public Health with Open Source. Today, we have a session where we'll be talking about what it looks like to implement open source tools in mixed environments. We'll hear from panelists Justin and Joe. And Casey, our colleague, is going to give us some background on maybe some considerations you might have when selecting new software, whether that be open source proprietary or in a mixed environment. A little bit about us. My name's Sonora Stampley. We are part of the Digital Initiative Group at the University of Washington. We do a number of projects that address a range of issues around digital health. We have a more technical side of the house, in addition to a more capacity development side. So our work ranges from accelerating health outcomes through effective digital health tooling, to technical advising. So as we kick off today, we'll cover some key factors to consider when selecting technology. This will include some advantages and disadvantages of different kinds of software models. We'll talk about how those work within a single health information exchange environment and some challenges and solutions for using open source solutions in that environment. And as we kick off, we want to hear a little bit from you. So we'll go over to Mentimeter. We'll have one quick question. We want to know what the top factor for you is when you're considering choosing a new or different piece of software. So we'll go ahead and drop the link to Menti in the chat. And thanks, Jen. And go over here. And we already see some responses. This is great. Cost, features. Let's see, keep them coming. Sustainability, that's a big one. Compatibility, fit in architecture, interoperability, okay. It's like sustainability is kind of rising to the top. Maybe we're getting a few more responses there. Might give just a little bit longer in case folks have other thoughts to add. Limitations. That's interesting. We're stabilizing a bit here, but I think we'll touch on a lot of these topics today, thinking about what sustainability, cost, and interoperability look like when making these choices. And on that note, I will transition us back to our slides and pass it off to Casey.
All right. Thank you so much, Sonora. So health systems are complex, right? When we talk about health systems, we're not usually talking about just one piece of software, one application, even though some of the best designed ones might even feel that way or have one interface for things. But usually it's a mix of different systems working together. So in the diagram, we have some different examples of how this ties together, both on the point of care side, so the systems that staff are interacting with in health facilities, things like electronic medical records. So those might be your Epics or Cerners or OpenMRSs. Lab systems, things like Labware, OpenLS are examples of lab systems or pharmacy systems. These are all independent systems that tend to be uh, built for purpose, so they're best fits for doing what they do. And then they're all linked together using standards. In some cases, those are open standards, which means that they're published and available free of charge. Anyone can use them. Sometimes they're closed standards where you have to license them in order to use that standard, or they might even be proprietary APIs. But the main takeaway is that most systems are a mix of open source systems and closed source systems that are all working together using interoperability. All right. And then the next slide. Well, we're going to talk about three different types of software, and it's really important to define what exactly we mean by these different types and what are some of the advantages and disadvantages of each. So the three types of software we'll talk about are proprietary software or closed source software, open source software, or custom built software. So if we go to the next slide, we'll talk about proprietary software. This is your commercial software, so things that you might be familiar with in the healthcare realm. This is your Epic system or your Labware system. This is probably also what a lot of you use for your operating systems, things like Windows or Office. These are all examples of proprietary or commercial software. Oftentimes, this software will come with warranties, really good documentation, and some kind of organized customer support that's included or an extra cost with that proprietary software. It should be very reliable and very well tested since these are commercial solutions. They'll receive regular patches and security updates, and usually it's significantly cheaper than building your own. Some disadvantages to this proprietary software, it can be massively expensive. I think anyone that has rolled out Epic in the hospital system will gawk at the amount it costs, but I think I've heard numbers like something $20,000 for every single bed in a hospital winds up being the cost to actually implement some of these closed source solutions. There's less customization, so whatever already exists is likely what you're going to get. You can have vendor lock-in, which means that once you've selected that software, changing to another type of software could be extremely difficult if your data is saved in a proprietary format. Sorry, need more coffee. And then finally, you've got sort of limited control and you're dependent on support from that commercial software organization. The next type of software we're going to talk about is open source software. So this is pretty great stuff. It is usually free and open source, but like a good friend of mine likes to say, it's free, but it's free like a puppy. Once you have adopted this open source software, you're going to need to invest something in keeping it running, keeping it up to date, and making sure that it's got some of the features maybe that you're looking for. It's made for the greater good and nonprofit by a community and is shared freely. So there should be very low barriers to entering for open source software. Uh, it can move rather quickly and be a lot more fluid than some of the commercial software, just because of its orientation and that there's a lot more folks in the community that are determining the direction of the software rather than needing to wait for a large company. Open source software can be adapted a little bit easier since the source is available and customizations can be made. And finally, it can be very reliable and secure because there are so many people that are in charge of looking at this and that are maintaining this at a high level. Some disadvantages are open source software can still exist out there on a GitHub, but be functionally a dead software. This is when things haven't been updated for a long period of time. Maybe there are critical security vulnerabilities, or even the software won't run on modern architectures without needs for updates. Um, and then finally, customer support and end user documentation can definitely be limited. So you might need to actually join the communities and work with them. There may not be organized documentation as available. It just depends on the product. And of course, there's no warranty, as there is no service contract or anything implied with open source software. Finally, we're going to talk about custom built solutions. This is usually the thing that people think that they want the most at the outset, right? It will always meet all of your specific requirements. It ensures that the workflows are exactly what you're looking for your use case. Support is there because you know the folks that built it. Um, it can be developed according to whatever guidelines or needs that you might have, and there's lots of flexibility. You also have control over when updates happen, so you don't have to wait for a release for new features or bug fixes, since you'll be the one doing the release. Of course, the downside is now that you've built this thing from scratch, you now own it. So this is not just adopting a puppy, but inventing a puppy. And now you need to learn how to care for it, do all the care and feeding yourself, and maintain knowledge within your team, which can be massively expensive over time. And it means that the maintenance costs will also be a lot higher because you can't rely on a community or a wider pool of knowledge. You can also, of course, whoever's building your software, you're extremely reliant on them because there's not going to be any other options that really truly understand this software. So that is what we mean when we say custom built solutions. And on the next slide, we're going to talk about an excellent paper. You can see this QR code here. And of course, we'll have the recording and slide deck available after this talk. But this paper has been published, and it will help sort of it explores how open source technologies can support public health initiatives in the United States, particularly. It highlights the benefits of open source software, like flexibility, transparency, and cost savings that we just talked about, and also addresses some of those challenges like governance and sustainability. So please go ahead and check out that paper. Definitely, there will be links in the slide deck. So this will sort of tell you how public health authorities can approach open source solutions with real life case studies. So with that, I'm going to go ahead and turn it over to our speakers. I'm not sure if Jen, are you doing the introduction?
Yep.
Perfect.
Great. Thanks, Casey. And hi, everybody. I'm really excited to have you all with us today. My name is Jen Antella, and I'm an informatics project lead and instructional designer here at Digi. I've been working with open source products and communities for about 10 or 15 years now. And one of the things that I really value about the open source world is the way it brings together colleagues from different organizations, from different countries, from all over the place, and kind of creates this space for collaboration, to share knowledge, to share experiences and solutions. And that's exactly what we're going to be doing for the next 40 minutes or so. It's my pleasure to introduce two people I have had the pleasure of working with over the years. Justin McReynolds has a Master's of Science in Biomedical and Health Informatics from the University of Washington School of Medicine. And he is a technical program manager with the Clinical Informatics Research Group at the University of Washington. He's worked in health informatics for over 20 years and wears many hats: team lead, engineer, designer, informaticist, budget and proposal writer. And he aims to address problems with tech appropriately and not amplify them. And I can relate to many of those different hats, Justin. Our other guest today is Joe Emling. He is a senior technical advisor with the Regan Street Global Health Informatics Program, and he works internationally to bridge the gap between health data standards and local implementation. He provides hands-on support with teams to promote data standardization while also maintaining a strong commitment to equity and local empowerment. He also oversees the Open Concept Lab terminology management tool that combines open source principles with best practice data standard solutions. Justin and Joe, welcome. Super excited to have you with us. Um, Perhaps as a starting point, um, could maybe we'll start with you, Justin. Could you tell us about a project where you've implemented open source products or software, and tell us a little bit about the client and what the project was all about, what it was trying to achieve?
Sure, yeah. And thanks for the introduction. I did have a slide in the deck that is kind of complicated to look at, but for me, it's helpful to have as someone's describing a system, something to kind of poke at and look at a little bit. So this is an example of a system that we are currently run and have built over the past 5 years or so. It is a uh, clinical opioid summary with prescription integration software system that we call it COSRI that we run for uh, clinics in Washington State. It is based around an open source project that MITRE built for AHRQ several years ago around clinical guidelines and computable clinical guidelines. So Casey mentioned standards earlier. All our group's work is built on standards, and this is an example, a great example of open source software that we adopted, brought into a larger system, and put into practical use. And another really cool facet of it is that not only the software, but the logic in the clinical decision support is in a format called CQL, which is a language that is it has gotten a lot of traction in the past 5 years in the open standards health community for implementing logic, for designating logic around different aspects, usually clinical decision support. And so it, for example, um, computes a morphine equivalent dose of medications that we present to physicians as they are deciding whether to prescribe pain medications. So this diagram is big and unwieldy. I'm happy to share a list of open source repositories that we utilize here, but there's probably in this stack, I would say at least 2 or 3 dozen different open source software pieces. And I'll come around later to some kind of fuzzy lines like commercial software that is made freely available. That we use a bit of that as well. In general, our group uses almost all open source software. Um, and so this, as I mentioned, the standards this uses, Smart on Fire is another standard that this uses. And so on the left, we have an EMR, and on the right, we have a Smart on Fire client app that is launched from the EMR and presents the clinical decision support. And there's a lot of this diagram really gets into the nitty gritty of like for example, an open source Fire interface that we wrote to interact with a commercial uh, prescription drug monitoring program that's run in Washington State, and that doesn't serve fire. So we wrote a wrapper that we open source. We tend to open source almost all of our software, and so we translate that standard into that other standard into fire, which can be consumed by our Smart on Fire client app. And so lots of details here. I'll share links to repositories to those who want to poke around, and get a better view at the code or whatever. And that's Cosry in a nutshell. Happy to talk about more details as we move along here.
Fantastic. Thanks for that overview of the project. Joe, how about you? What projects have you been working on? Is there a particular one where you've implemented open source solutions? And can you tell us a little bit about that project and the client?
Yeah, absolutely. And I hope my audio is coming through well. Okay. I'm here today on behalf of the Global Health Informatics team at the Regan Street Institute. I myself am have more of a public health data analyst background, but our team as a whole is a very huge proponent of the open source approaches as a whole. That, of course, does include software like the Open Concept Lab, which I will talk about a little bit. But that also includes other products that are open, like the Open HIE Health Information Exchange standard and architecture that we put out there. The Open HIE Academy that comes with that, that is a freely available set of courses where people are able to see all of these courses for free. And the only time you pay is to take the certification and basically have those qualifications underneath you. In general, we are using or maintaining our own open source softwares, communities, whatever they might be. Some projects where I've been on the user side of open source has been, as an example, there was a project with our Indianapolis Emergency Medical Services during COVID times where essentially they needed a very quick medical record stood up to be able to triage patients and collect data in parking lots when hospitals were too full of patients. This was done using open source, OpenMRS software, among others, to go ahead and get us started. There have also been more international efforts that we've taken on, such as with Kenya. There's a couple of examples in particular where we experimented with smart guidelines for the use of indicator calculation using smart guideline standards that are set by World Health Organization. Similarly, Kenya's National Health Data Dictionary was another effort that I was privileged to be involved in, where they were setting up a open source terminology service, but in a local setting where they had full control and, for better or for worse, full control over the system, over the software as it was deployed, so that it could be used as part of their national digital health superhighway. In addition, I've just always been a dabbler when it comes to open source tools and even proprietary tools, trying to find different ones where I can do data transformation and whatever is needed to just accomplish the goals as needed. So definitely an experimenter on the user side. From the maintainer side of open source, I do a lot with the Open Concept Lab terminology service, which this is a terminology management software that itself is open source. One of the things that sets it apart is that it also has a deployed shared service where people are not only able to use the software right away online, but also share in each other's content. And again, for better or for worse, they are, they get involved in the ongoing management and governance of terminology content, but it's with each other with a community-centric lens. So throughout this today, I'll have a few projects that I might talk about, but sometimes it'll be from the user perspective, sometimes it'll be from the maintainer perspective of an open source product.
Great. Thank you, Joe. So, both of you have talked about, open source products ones you're working with, or as a user or maintainer or developer implementer, and both of you, it sounds like, are making these tools work in environments, in kind of mixed environment that Casey spoke about earlier. Maybe there's, proprietary software or even other open source software tools. I'm really curious to hear, from both of you, in your experience, what really drove that decision to use open source in your projects? Either one of you can answer that question first, but what really drove that decision?
Sure, I can, with Cosry as an example, our team does does mostly open source. So and we do custom software. Our team develops custom software as well. So just with that caveat, um, but so the in the Cosry example, we're interacting with a commercial PDMP, as I noted, and and on one side of it, that's our source, and on the other side, we had this fantastic resource of this AHRQ developed um, computable guidelines and the open source and fire communities um, implementations, reference implementations of smart on fire applications, and services, reference services running out there like smart on fire hosts that one can test against. And so to have that big community and to be able to try out different subcomponents of what is a fairly large, almost enterprise level system like Cosry, is really valuable, and to engage with the community and be able to talk with people in the standards community. If you go to an online community like chat.fire.org, you can talk with the people who develop these standards and build reference implementations, open source reference implementations. So there was so much to be drawn from there. Now, there are many steps to get from there into production clinical implementation, which is what Cosry is, and so many aspects, uh, security, infrastructure, that sort of thing that one needs to deal with in any production implementation. But and we certainly rely on a lot of open source tooling for that as well. But that's kind of in a nutshell from my side.
So, Justin, if I can just ask a follow-up question, you said that your team usually works with open source tools. Um, in that particular project, were there other people involved in making the decision to go with the open source tech?
Yeah, we it's always an interesting discussion.
Yeah.
Like the slide of proprietary versus custom versus open source. Like for us, as I mentioned, we have a development team where we have about 10 engineers. And frankly, like many groups, we're spread thin. And there's always a decision, do we build our own some version of a component um, to fit exactly what we need, or do we take an existing open source piece of software and maybe fork it and change it to do what we need to, or maybe keep use the don't fork it and just keep the original and use that. So those are some lines. And as far as decisions go, it's usually talking with engineers, talking with stakeholders to figure out, do we want to make an investment? What kind of investment do we want to make here? Is this a tool that we think we're going to use more widely across our group, and for future projects, and that we don't mind investing, if it's an open source project, investing the time to integrate it into our system, to understand it, engage with the community, And of course, there are many levels of components that we're talking about here, from low-level JavaScript libraries and front-end libraries like Bootstrap on up to something like OpenMRS, and so for each of those, groups make decisions every day around these sorts of things, and our general go-to is open source. And if it doesn't quite work, or we need to implement something around the edge to bring it in, then we go a custom approach. And as I mentioned earlier, we do leverage some commercial, especially free offerings from commercial outfits, but they have their own risks because they can pull the plug at any moment and change their licensing or cost model.
Great, thanks. Joe, what about you? On some of the projects you're working on, what's driving the decision to go with open source?
Yeah, there's quite a few things, and I did actually want to follow up on one of Justin's points about chat.fire.org in particular, although I find this very commonly in lots of open source products and the surrounding communities. Those kind of forums and those communication venues are, in my experience, very, very responsive and very, very helpful in what they're doing. And I think part of that is you're not only interfacing with the developers or the maintainers of the product itself, but oftentimes you're interfacing with a community who has come up with this exact same problem and have themselves experienced what needed to be done. So open source, in my mind, there's a lot of success and sustainability as a result of the accessibility and collaboration that you can get out of that. The more people that are able to come to the table and provide their inputs and their experiences, not only do you tend to get more help in the moment, but you also tend to get a better variety, a better generalizability of the resource, of the inputs, of the goals, and it helps shape that product into being something that can, in the long term, be more useful to people. Proprietary software certainly can do that too, but when your customer base is more the people who have paid into your services or paid into your product, you may get a smaller variety of voices that have come to the table and maybe provided their inputs and sometimes even providing their own contributions in whatever ways those might be. Many of those can be unexpected, and we've with Open Concept Lab had some extremely standout community members who we probably never would have heard from had there been some kind of paywall in order to start using the service. Just additionally with open source, as I said, I'm a tinkerer. I'm someone who likes to play around with different products and find something that will work for the use case so that we can have that informed decision on, is this going to actually get where we want to go? With these open source products, that accessibility to go ahead and get started to try something out is something that I have found extremely, extremely helpful. As I said, with Open Concept Lab, we've got the software, but also the shared service, which is extremely helpful. Whereas some products out there may make their software freely available, but you may not have the content, the data within it to do something meaningful with. And so open source products tend to have that ability to explore, to try it out, and maybe do some small time use cases for integrating it into what will eventually be a larger product. We often are promoting people doing those small experimentations to start building local capacity and get people understanding, where is this tool really going to lead? Don't just use it because it's a big name, but make sure it fits into your health initiatives. And the open source approach has really helped us with that.
Fantastic. I'm kind of curious, thinking through, you've got the buy-in, you've got the green light to go ahead and do this project. Now you're actually implementing it. Can you both tell us a little bit about some of the challenges that you've come across during project implementation in some of these mixed environments, and how you ended up solving them?
Yeah, I think I can come up with at least a couple of examples here. For the Indianapolis EMS project, where we were standing up OpenMRS, One of our challenges from the start was a rapid deployment cycle that we had to get something up and running and customized extremely quickly. And there was no way we were ever going to be able to do that without an open source software like OpenMRS, which, not only did we understand the documentation well, but it was so easy to modify to the way that we needed to be, to the information we needed to collect, and to the endpoints we needed to hit. We were able to make good use of that, partially also because of the standards-based nature that OpenMRS and its underlying metadata was promoting. We were able to use that to link to even proprietary softwares like our health information exchange in our state that is much more locked down. It's something that is not as open as OpenMRS was, but because of the standards-based nature of it, we were able to overcome what could have been a interoperability nightmare. Other challenges that you might come up with, which I think is maybe more common in open source, is that you are probably going to find bugs. You're going to find things that, okay, wait, I ran into something, I wasn't expecting that. And something that has been very helpful with the open source community aspect of that is we are free to engage with that bug, and we aren't just reporting it as a ticket. We can have a pull request with code contributions to say, here is what I think needs to be done for this. And if you like it, then accept it. And it's something that is much quicker and much more much more encouraged in the open source community, which we've really enjoyed.
Right. Justin, how about you?
Yeah. So a lot of things that Joe referenced there, we've run into as well. And, every piece of software is written for a particular set of use cases. And some software is, more generalized than other pieces of software. And so it's often the case where we'll bring something in, implement, do a test, as Joe is saying, like open source software is great for tinkering with. So we'll bring something like a library that converts CSV files into Fire, for example. Like that, just an example, one of the many toolings in the Fire community that people have implemented, and finding there that their use cases were slightly different. They assumed, a certain version of Fire, or maybe some of our data was created 5 years ago, and doesn't conform with the version of Fire that they expected, and so uh, you know engaging with the community, as Joe mentioned, um, to implement more capacity in an open source project. That's one option that we take sometimes. Sometimes we write sort of wrappers or small utility pieces of code that will translate formats, and sometimes we need to write a data migration on our side that makes our data more standard conformant, or change it in a way that just works better with a particular piece of software. So those are some challenges. Other things like the cause Ray mentioned. So we forked that code base, and the computable guidelines there to make them conformant to Washington State's guidelines, which have a slightly different calculation for the morphine equivalent dose that software makes. So we forked it, and so there's like different levels. If you fork a piece of code, is the code organized in a way in components where you could fork one part of it, like one repository, and there's other repositories that work with it, and you can. So that's something when you're considering an open source project, looking at the code, like, is there kind of an ecosystem around it? And there's always kind of give and take there is like, is it too rigid? You know, do they assume that you're going to kind of buy into their entire model of doing things, or can you take just a component? So in our example, Cosry is kind of a one repository, the way it was written, or I'm sorry, the morphine equivalent dose calculator. And so as a Smart on Fire app and all the computable guidelines in it, like that's one repository. So we forked that. And so when we want to get updates upstream from the original project, we need to bring those into ours. And it's a bit more work to do that than it would be otherwise. But these are just balances that, you know, as you build a system like this and think about in the long run, maintainability, level of support from the community, and as was mentioned earlier, you know, when you're considering a repository, look for recent updates. Is it still being updated? Are the developers, the community reachable? Like, you know, you can oftentimes in the health informatics space, look at the developers, find them on Zulip, as we talked about. You know, are there many forks of the repository? Have many people taken it and kind of run with it and done their own thing? And it's kind of worth looking at those a little bit to see, you know, because sometimes you'll start somewhere and actually a fork has done something of more in line with what you're looking for. And then just generally like doing some web searches and seeing, like, do you find other people using it, you know, and references in other communities and that sort of thing. And tests as well. It's good to see tests in the software that are runnable and maybe part of the repository when people commit to it, you know, it's running tests and you can see that it's being kept up to date and that sort of thing.
Well, thank you. You're kind of setting up my next question for both of you. You've both done that in slightly different ways. I want to talk a little bit about successes, right? And I think we've all been around a lot of these different projects, and there's usually, you know, what's going to be, what is a successful outcome that you write down on paper that you set out to achieve at the very beginning. But Joe, you mentioned in the chat sneaky successes. I'd like to hear more about sneaky successes and what are some of the successes that you've experienced and seen with your open source projects?
Yeah, of course. And those are kind of just some upfront planning pieces. The contracting process is always interesting when you're stating what your goals are going to be for that project. You know, they are often like, all right, here's something very short term, here's something very concrete and measurable. These sneaky goals that we think about in addition to it are thinking, how does this project contribute to the broader ecosystem? In some cases where this is providing services to an implementer, such as with the Kenya Smart Guidelines or National Health Data Dictionary, nothing that we make should be applicable only to a single country. It's something that we want to be reused in the future. We want to be able to keep coming back to these resources and reusing them. In the case of software like Open Concept Lab, some of these sneaky goals are, you know, we are getting we might be getting some core funding support, or we might be getting code contributions from people, and we are hoping we redirect them towards things that will be able to benefit the community at large. So these sneaky goals sometimes just, they sit slightly outside of these contracts, but in reality, they are something that are agreed upon that all parties realize we do need. And it's like, yeah, we're not necessarily funding that explicitly, but people love to see those additional products that come out of it and contribute towards the long-term nature of it. Just some additional successes, Jen, to answer your other questions. One of the main things that I think the open source communities tend to really promote is local capacity strengthening and having sustainability through that. The last thing that many of us want to do is, you know, come in with some services, and then the second you stop paying, then all right, we are back out and you're back where you started with no real support. Even if you have software still in place, can people locally still support it? Local capacity strengthening is something that we are always really trying to promote for people. and making sure that our success will be eventually that you don't need us anymore. For Open Concept Lab, we don't want to be a service provider so much as we want people to have their own product ready to go, and their contributions come back to us maybe in code or requirements or whatever it might be. But in reality, you're self-sustaining, and that's our primary goal there.
So connecting it to something, Justin, you mentioned it sounds like one, you have the project goals and project successes, but linking them back up to successes that would make the open source product more active. If you, for instance, were to go to their GitHub repository, you would hopefully, if you're achieving what you set out to achieve, you'd have a lot of activity happening there back at that main repo. Justin, curious to hear from you. What are some successes you've seen, and how do you look at success?
Sure. Yeah, our projects run a really wide scope, from clinical, public health, consumer health, peer research. And so our measures of success really vary quite a bit just from the project side. But from the software side, like there are some software components, some open source software components that have kind of stood the test of time for us, like Happy, the Fire server, which is used so widely in the health informatics community, as a non-production tool and a production tool as well. Even though and that's an interesting example of a company, Smile CDR, having their proprietary version, and then an open source version as well, and that the proprietary version is built on top of the open source version. And so we use Happy, as many organizations do, and we've needed to implement things around it that Smile CDR offers commercially for what can be a very steep price depending on the project in the organization. So for us, things around that, like Keycloak, which is the authentication and authorization web-based system, to have those two together, and components that enable communications across them and interactions with other systems, and having bringing in identity providers through those and for access to the system. Like, those are examples of a couple open source projects that for us have stood the time. And one is Keycloak is not specific to health at all, and so you'll always, of course, have a mix of those kinds of non-domain specific projects, very large projects like that, and the health ones, which tend to be a little bit smaller. And so I think there's a lot that can be done using almost all open source, and you know even in a production system, and but always trade-offs there around writing your own bits of glue to keep it together, and to make it all run smoothly.
Yeah, great. Thank you. So, I have one last question, and then I want to see if we have time to take a few questions from the people here with us today. You've both talked unprompted, totally unprompted, about a lot of the different aspects about working with open source products and their communities. I'm curious if you can share any misconceptions or challenges that you encountered along the way working with these open source communities. And these could be misperceptions or challenges you've experienced, or that you've heard others bring up or others experience.
I think one of the biggest misconceptions that I've historically seen, and I put a little bit of this in the chat that I just put in there, but one of the misconceptions I see a lot of is that in order to give back, you have to be a developer, that you have to contribute code, you have to have that kind of technical skill set. And that, at least in my experience, couldn't be further from the truth. I think there is a variety of skill sets that are all extremely, extremely valued among open source communities. And you're sure code contributions are one, but also requirement contributions, community leadership, uh, just doing little things that seem like very little to you, but actually end up really strongly influencing the direction of the product. I can think of a few people on hand. For example, Lynn from the Open Concept Lab community that one day just gave translations for the entire application from English into Chinese that we didn't ask for it, but it immediately brought value to the entire community. We have people who have stepped up on initiatives, technical initiatives, to say, all right, I am going to rally the troops essentially and help to align, here's how we're going to do this. I'll be the project manager. I'll be the lead on this. Even if you never contribute a bit of code, you're more bringing the right people in. And sometimes even just giving a paragraph of your success story, like this has unlocked us to standardize information as part of our broader health ecosystem. Whatever it might be, those kind of things are all extremely valuable, even if you've never written a bit of code in your life.
Fantastic. Thank you. Justin, how about you?
Yeah, I think in general, the people who write this type of software want to see it being used and are generally responsive and with information. And oftentimes, some of these projects are written on a shoestring budget, and maybe the documentation is oriented to a slightly different environment or use case. And but we found that oftentimes the original developer will respond and give some pointers, and in some cases, is excited to see the use and will kind of, might respond with, "Oh, hey, I've been meaning to commit this change, or this just needs another set of eyes on it. Can you have a look at this? And I think this is gonna, you know, solve your particular problem here, but I've just been waiting for someone else to review it," that sort of thing. I think that there's a level of altruism in the community generally that helps out a lot around that. And so I mentioned earlier, that challenges, you're always going to need someone who can write software around the edges to bring it together, and to do that sort of thing.
Great, thank you. Well, everything you said about open source and open source communities, I feel like it comes up, but in different ways, because open source products that are not all the same, the communities are not all the same, but they do kind of experience some of the flavors of success and the challenges that you've both described. Before I turn it back over to Sonora, I just want to see if if anybody else who is with us today have any questions for Justin and Joe. You can either come off mute or, put them in the chat.
I will say, I actually thought Daniel's comment slash question that he had asked earlier, and Jan and I have been giving some replies to that. I thought that was a very, very good question because especially in the global public good space, many of these products were somewhat dependent on grants from either global funding organizations or from US-based specifically organizations. I know PEPFAR, USA, those were some sources of income for the Open Concept Lab team, where now we've had to become more lean of it. But in addition to that, that has also forced us to go into a model that we've wanted to for quite some time, the more community-centric, people-centric model. So in some ways, we're trying to take this crisis and turn it into sustainability that is dependent on the community that uses the product rather than the funders who have heard from the community that they need the product. So we just change what success is for us. It's not as much about the dollars that come in, but more about the usage that comes from the community.
Great. And yeah, so for those of you who
have
haven't
a
seen the
question.
question, it's how do you foresee global health open source software projects in the context of the US
I have a
government increase in foreign aid? And you can see the responses in the chat. Somebody else had a question?
Hello.
Yes, Brian, go ahead.
Just maybe a question to Joe, if maybe you could expand, because I remember him talking about a project he did back with the Kenyan team, the National Health Dictionary. Could he maybe just expand a little bit about it?
Yeah, of course. And I want to note that this project was a mixture of not just software, but in addition, setting up content and governance around a national health data dictionary, which is intended to power a Kenya digital health superhighway. So essentially, this national health data dictionary is intended to store health data standards that can then be published and integrated into various Kenyan systems, which include both open source systems like OpenMRS and Kenya EMR, and other proprietary systems such as Appia KE and things like that. The idea that there are these standards in place with trainings, with resources, with actual people who are intended to maintain that over the long run and support systems in integrating these health data system standards so that they could better exchange data across the country. This is something that is still very much a work in progress, although there is a stand-up of the terminology service itself. But the other important aspects around it that are not software are still kind of in the works. And those are really driving key pieces that turn this open source software into something that is more successful and widely used.
Great, thanks, Joe. And I actually just wanted to thank both of you, Justin and Joe, for joining us today, sharing your insights, your experiences. This has been a fantastic conversation. It's gone by way too quickly. And I'm going to just turn it back over to Sonora to wrap things up and share what's happening next with our webinar series.
Yeah, thanks, Jen, and a very full-hearted thank you to Justin and Joe for joining us today. It was a great conversation that I really enjoyed listening in on. Justin, I particularly liked your comment about kind of the altruistic nature of these communities that we work with. I think that really resonated with me, and it kind of helps us expand on not just the stated end goals and products of some of these projects, but the learning and sense of community that can come out of it too. And I think today's last hour is a great example of that. So if you want to learn more about us and the Digi team, you can visit us at our website. We'll be sharing out a link to the recording of today's session to everyone who registered. You can also access that recording from the website. We do have a quick post survey, just 3 questions. So we'd love to hear from you guys. We'll drop a link to that in the chat shortly. And lastly, want to make sure that you have the link to register for our 3rd and final webinar in this series, where we'll be doing another deep dive into what applications and real-world impact of different open source solutions can look like. That'll be next week, May 28th at the same time. You can register using the QR code. So with that, again, thank you to everyone who was able to join today. We hope to see you again.